Hello, my name is Whitney Otan. I'm a professor of geology in the Department of the Earth Sciences, and I'm preparing this video in order to assist you in ESC 195 natural disasters and your laboratory exercises. Each week for your lab exercises, I will have a short introductory video that explains the concepts of the assignment. Today's exercise is associated with making stream flow measurements. And in order to do so, we need to have an understanding of a few concepts and ideas about what a river channel is all about. First place, a stream channel that carries flowing water can be measured in what would be referred to as a cross-sectional area. The area has a width and a depth. Now, in natural stream channels, width and depth would vary perhaps irregularly across the stream cross-section, but what we do to get around the complexities of the mathematics, we will estimate an average width and an average depth. Now, the cross-sectional area basically provides us with the information which would allow us to then look at how much water is passing through a given position in the channel. So in order to do that, the next thing we need to do is understand how fast the stream is moving. This would be the stream's velocity. In natural stream systems, the velocity is variable from point to point in the cross-section. You would get areas of maybe more rapidly flowing water and slower flowing water. As a result, we tend to measure an averaged velocity, and this average would be representative of the overall flow of a given cross-section. From that point, we can then estimate, if we know the average depth, the average width, and the average velocity, we multiply the three products, and then we can get the average discharge. Think of discharge as the volume of water that passes a cross-section over time. So we tend to measure discharge in the units of cubic feet per second. Think of this by analogy to what you might see if you watched automobiles passing on the interstate. Think of an individual automobile as one unit or 1 cubic foot. If you watch on the interstate, you might see if the traffic's flowing very fast, maybe per every minute you might see 50 or 100 cars passing by. If you're in a traffic jam, you would see maybe only a few cars passing by. This would be analogous to a high discharge versus a low discharge. Once again, discharge is the product of the average width, the average depth, and the average velocity of the stream. Stream discharge is also associated with the level or the elevation that the water rises in a stream. As a stream rises during a flood, discharge will tend to increase. At a certain point, when the river rises to the point that it fills its channel, at that point the water will flow into its floodplain. It will leave the channel banks. The point at which the channel is full is called the bank full discharge. Discharges that are greater than bank full discharge would tend to cause flooding across the floodplain. At that point, if we have people, buildings, and our interests, such as our infrastructure, in the floodplain, we can at that point experience a disaster. The higher the flood levels come, the greater the geographic area that would be flooded, and therefore that would tend to increase the chances of hazard and potential disaster. Understanding that this is a very brief introduction, think about the concepts of stage, and discharge related to the nature of the calculations of estimating the average width, the average depth, and the average velocity. And for any stream channel, if you have this information, then you can calculate the discharge, relate it to the stage, and then understand the hazard and risk associated with river flooding. Thank you very much for your time and attention. This is Whitney Otan signing off. We will be back to you next week with another video explaining next week's exercise. Have a good day.